Today we're going to talk about section 6.4, which is on using the inverse function. Our goal is to find inverse functions. So the first thing we're going to talk about today is an inverse relation. And that's a relation that interchanges the input and the output values of the original relation. The graph of an inverse relation is a reflection of the graph of the original relation with the equation y equals x as the line of reflection. So when we talk about graphing these, remember here it says we interchange the input and the output values. The input values are x values, the output values are y values, so we're really switching the variables x and y around. So when we come to example 1, that's exactly what we're going to do. We're going to find the inverse of this relation. We're going to switch x and y, and we're going to solve it. So if we do that, we get x equals 4x plus 2. So subtract 2 from both sides, we get 4y, and then we divide by 4. So we get x minus 2 over 4 equals y. Now if I want to write that as a linear function, then I'm going to write it as 1/4 x minus 2/4, which is 1/2. And I'm always going to write this as f inverse of x. So that's how we say this part of it. That little one means the inverse, and you do have a button like that on your calculator, but that little one means the inverse, so it's the inverse of f equals 1/4 x minus 1/2. So here we switched the x and the y value, and then we solved it for y. So the inverse function, there's a function f and g are inverses provided that f of g of x equals x and g of f of x equals x. Now the function g is notated or is denoted by f inverse of, or f inverse 1, which is read the inverse of f. Now you can't really see it on there, but that should be f with that little negative 1 again. So we want to verify that these are in fact inverses. So what we're going to do is we're going to find f of f inverse of x. And remember, we're going to take the inverse function, because that's the inside one, and we're going to put it into the other function, because that's the outside one. So we're going to go 4. Now instead of x, we're going to write the 1/4 x minus 1/2, and then plus 2. So from here, we do our distributive property. So we're going to get x minus 2 plus 2, which equals x. And so it equals x. That's what we wanted it to do. And for the second part, now we're going to go the other way. The inverse of f of x. So f inverse of f of x. So now we're going to take the f of x function and we're going to put it into the other one. So we're going to have 1/4. Now instead of x, I'm going to write my 4x plus 2. And then subtract 2. So if we do the distributive property, we're going to get x plus 2 minus 2 equals, again, x. And there we have just verified that these two are in fact inverses, because f of f inverse of x equaled x and f inverse of f of x equaled x. So we're using the composite functions that we did in section 6.3 to verify that those are in fact inverses. Well, if we jump down to example 3, we're going to solve multi-step problems. Okay, a small company produces greeting cards, cost C in dollars, producing n number of greeting cards per month, can be modeled by the function c equals 360 plus 0.6n. Now, in the other example, we switched the x and the y variables because we wanted to find the inverse. Well, that doesn't make any sense to do in these real-life situations. We're not going to switch c and n because they're two very different things. C is our cost, n is the number of greeting cards per month. So what we're going to simply do is solve it for the variable that we want to. The inverse, we're solving it for n. So we're going to go and subtract that. C minus 360 equals 0.6n. And then we divide both sides by 0.6. And so we're going to end up with a function, an inverse function of n equals c over 0.6 and then 360 divided by 0.6 is 600, so it's going to be minus 600. And so here is the inverse function for that model. Now for part B, it says use the inverse function to find the number of greeting cards produced in the month in which the company's total cost was $615. So what we're going to do is put that $615 into our equation. And solve it. And if we do that, we get n equals 425. All right, so that means 425 greeting cards were produced. So in a real life situation, we're just solving for the variable in question, and then we're plugging in our numbers. So we're going to take and we're going to do questions 1 through 3 in the guided practice. It says find the inverse of the given function, then verify that your results of the original functions are inverse. So we're going to switch the x and the y variables, solve it, and then we're going to find f of f inverse of x and f inverse of f of x. So go ahead and do one or a couple of those questions. I'll do all 3 of them, but you can go ahead and pause the video and hit play when you are ready. So if we look at these problems, the blue, everything in the blue I went through and we found the inverse of those functions. And then the black and the red we used to verify. The black ones I found f of f inverse, and I showed that each one of those equaled x. And then the red f inverse of f of x, I showed all of those equal to x. And so there is, we used our composite functions to verify that these were in fact inverses. Now moving down, we're going to look at the inverse of a nonlinear function. Well, remember, f of x equals x squared. That's our parabola. This is our parent function for the parabola. 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. If we would graph this, that's what it would look like. And so next, we're going to look at what is the inverse of this going to look like. Well, remember, we said that the inverse is we switch the x and the y. So instead of 0, 0, I now have 0, 0, which obviously is the same. Instead of 1, 1, I switch the x and y. Well, they're the same, so that's still going to be the same. However, the next one I have 2, 4, so I switch those and it's become 4, 2. Negative 1, 1 becomes 1, negative 1. And negative 2, 4 becomes 4, negative 2. And so now the inverse of my quadratic equation is the blue one. So the black graph is our original function, and the blue one is our inverse function, which is right there. We switch the x and the y variables. Well, the same thing is true for the cubic, and the quadratic and the cubic are the two that we're going to use most often when we talk about these. So we're going to have 0, 0, 1, 1. If we put in 2, we're going to get 8, so that's up here. And then negative 1, and negative 8. 2, negative 8. So that's down here. So there's our graph. Well, again, we're going to switch the x and the y values. So 0, 0 becomes 0, 0, 1, 1, negative 1, stay the same. However, now instead of 2, 8, we have 8, 2. And instead of negative 2, negative 8, we have negative 8, negative 2. And so this graph is going to look like that. So that's what we do when we find the inverse of these functions. So in example 4, we want to find the inverse of a power function. Now notice, one piece of information here is they restrict our domain. They say we can only use x values that are less than or equal to 0, which means they are going to be negative. So we want to find the inverse of this. Well, again, switch my x and my y. Okay, x minus 2 equals y squared. We take the square root of both sides. and we're going to get plus or minus the square root of x minus 2 equals y. However, we are restricting that to less than or equal to 0 for my x value. So this is going to be negative the square root of x minus 2 equals f inverse of x. So there is my inverse function. So let's graph these. We'll graph the original one in black, and I'm going to just plug a couple points in real quick. If I put in 0, I'm going to get 2. If I put in negative 1, because we remember we can only use x values that are negative or less than or equal to 0. So negative 1, I'm going to get 3. And negative 2, I'm going to get 6. And so here is the graph of the original one. Now remember, to graph the inverse, we could either just plug values into here, or we could switch our x and our y values. Well, if we have the graph, it's super easy to switch these, because now instead of 0, 2, I have 2, 0. Instead of negative 1, 3, I have 3, negative 1. And instead of negative 2, 6, I have 6, negative 2. And so here is our graph. And if you'll notice, this has to be a reflection about the line y equals x. So is that line actually a line of symmetry? And you can see that obviously it is. If you would fold that one over on top of the other one, they would be identical. So this is the inverse of our original function. So the next thing we're going to talk about is something called the horizontal line test. Now we've already talked about the vertical line test, and the vertical line test was we used to tell is a graph a function. Okay, so we were looking at the vertical line test, and if it passes the vertical line test, we know that our graph is in fact a function. So let's look at the first one. We want to look at that blue one on the left side. Is that a function? Does it pass the vertical line test? And the answer is yes. Okay? There's no line that we can draw that's vertical anywhere on there that's going to touch the graph more than once. Okay, so that's how we tell if a graph is a function, if it passes the vertical line test. Does every input have only one output? So this one is a function. Now, does it pass the horizontal line test? Is there any horizontal line that I can draw that touches the graph more than once? And the answer to that is no. It passes the horizontal line test. What that tells us is that the inverse of the graph that we have will be a function. Because if it passes the horizontal line test, that means that the inverse of this graph will pass the vertical line test, which is what we use to tell if this is a function. All right, so let's go over to the second one. If we look at this graph, is it a function? The answer is yes. It passes the vertical line test. This graph passes the vertical line test, so therefore it is a function. Okay, so does it pass the horizontal line test? And that is no. It touches right here and right here. That tells us that the inverse of the graph that we have up here will not be a function. So it fails the horizontal line test, which means the inverse will not be a function. So in example 5, we're going to find the inverse of cubic functions. Consider the function f of x equals 3x to the fifth minus 2. Obviously, that's not a cubic, but we do all of these odd ones the same way, the odd exponents. Determine whether the inverse of f is a function, then find the inverse. So first thing we're going to do is probably graph it. So if we graph it, I'm going to pull up my graphing calculator. I type that function in, and here it is. Okay. We look at the graph. Is this graph a function? Yes, it is. It passes the vertical line test, so the graph is a function. But what we really want to know is the inverse of function. And that is as well. There's no place on here that I can draw a horizontal line that will touch more than once. It may look like right in this area that we can, but it will still continuously go up. So it is a function. And the inverse is also a function. So we determined that it is a function. Now find the inverse. So we're going to, again, switch the x and y. So I'm going to have x equals 3y to the fifth minus 2. Add 2 to both sides. Divide by 3. And now we're going to take the fifth root of both sides. Move this up here. So we're going to have the fifth root of x plus 2 over 3. And that is the inverse of our function. So the inverse of the function is the fifth root of x plus 2 over 3. So next we're going to jump down a few of these guided practice questions. I don't want you to do, or you don't have to do all of them. I am going to go through and do numbers 5 and 7 and 9. Right? So they want us to find the inverse, then graph the functions and its inverse. All right, so go ahead and pause the video until you are ready to continue. And here are the answers to the guided practice questions 5, 7, and 9. The black dotted lines are the graphs of the original functions. The blue lines are the graphs of the inverses. And then I found the inverses there as well. Now we're going to jump to example 6 now. It says find the inverse of a power model. And again, this is a real life situation. It says population of a town can be modeled by this equation. So again, we're not going to switch the variables, the x and the y, or the, in this case, the p and the t. We're just going to solve for t. So we have p equals 16,500 t to the 0.15. Well, we're going to divide both sides by 16,500, so it's going to be p over 16,500 equals t to the 0.15. Now, if this was t squared, we would take the square root of both sides. If it was t to the fifth, we'd take the fifth root of both sides. So it's the same thing here, except for now it's a 0.15. So we're going to take it to the 0.15 root of both sides. Well, to do that, this is really going to be 1 over 0.15. We're going to raise it to that power because 0.15 divided by 0.15 is 1. So now we'd be left with t to the first power. So if I do it to that side, I have to take that root to this side as well. So I'm going to raise it to the 1 over 0.15. So if we do that, take 1 divided by 0.15, we're going to end up with 6.67 if we round it. Equals t. And then if we plug that in our calculators, we'll get t equals 16. So here, oh wait, scratch that. Here is the inverse of our function. So we have p over 16,500 raised to the 6.67 equals t. Now, jumping down to question 7, we're going to use that inverse model to figure out how long it will take for us to have a population that's 25,000 people. So we're going to plug that in. So we're going to have 25,000 over 16,500. We're going to raise it to the 6.67 power. And that's going to give us what t equals. And if we plug that in, t is going to be 16. Well, remember from our original problem, t was the time since 1998. So we have to figure out how many years would that be. And so 1998 plus 16 would be 2014. So the population will reach 25,000 people around 2014. So in this section, in section 6.4, we're talking about inverse functions. We talked basically about three major topics. First, we want to find out how to find the inverse. Okay, so we switch the x and the y values, unless it's a real life situation, but we switch the x and the y values and we solve for y. And that is our inverse. We also talked about verifying that two functions were inverses. Well, to verify, we showed that f of f inverse of x equaled x and f inverse of f of x equaled x. So we're using our composite functions from section 6.3 to verify that these are, in fact, inverses. And then we talked about how do we tell if a function is, if its inverse is a function, and that is the horizontal line test. So if we graph our function, if our function passes, or if our graph passes the horizontal line test, then we know that the inverse of that will also be a function. So here is the homework set for section 6.4.